energy transformation. Energy transformation is important because the form of energy available to us is not always in the form we need. Let's look at some examples to understand why transformation is necessary. So on the left we see a fireplace. Burning wood releases chemical energy, which is converted into heat energy. We need this transformation to feel warmth. We can't use chemical energy directly. Here is a fan. A fan requires electrical energy to run its motor and spin its blades. Without converting electricity into kinetic energy, the fan won't move. On the right, we have a battery-powered light bulb. Here the battery stores the chemical energy, which is converted into electrical energy and then into light energy. This is how devices like torches work. So different devices need different types of energy, and energy transformation helps make energy useful for us. This slide shows how energy changes form when an object moves on a curved path. Imagine a ball placed on a U-shaped track. Conversion of potential energy to kinetic energy. At the top of the curve, the ball has maximum potential energy because it's at its highest point. So, as the ball travels from highest to lowest point, there is conversion of potential energy to kinetic energy. Now, conversion of kinetic energy to potential energy. As the ball travels from lowest point to highest point, there is conversion of kinetic energy to potential energy. See, at the lowest point of the curve, the ball moves the fastest and has maximum kinetic energy, but very little potential energy. As the ball moves up the other side of the curve, you can see kinetic energy is converted back into potential energy as the speed decreases and height increases. This back and forth conversion keeps happening as the ball moves, as long as there is no friction. So this demonstrates the conservation of mechanical energy. Plants are incredible. They can make their own food using light from the sun. Light energy from the sun hits the leaves. Inside the leaves are tiny structures called chloroplasts, which absorb this light. The plant takes in carbon dioxide from the air and water from the soil. Using the sun's energy, the plant converts these into glucose, which is a type of sugar, and it releases oxygen into the air. So this process is called photosynthesis. It transforms light energy into chemical energy stored in the form of food. When sunlight hits the solar panel, the energy from the sun is absorbed by silicon cells inside the panel. These silicon cells contain electrons. When they receive energy from sunlight, the electrons begin to move. This movement of electrons creates electric current, which is what we call electrical energy. This is a classic example of multiple energy transformations in a steam engine. First, coal is burned in the firebox. This burning releases chemical energy as heat. The heat boils the water in the boiler, producing steam. This hot steam travels through pipes and pushes a piston inside the engine. The movement of the piston turns the wheels. Thus, the heat energy is converted into kinetic energy. Now let's see how electrical energy becomes sound using a loudspeaker. When you play music from your phone or radio, electrical signals are sent to the speaker. Inside the speaker is a coil and a cone. These are placed near a magnet. The electric current flows through the coil, creating a magnetic field. This makes the coil and cone vibrate rapidly. The vibration pushes the air around it, creating sound waves that we can hear. So, what happens here? Electrical energy is transformed into sound energy through vibration and air movement. This slide shows how a battery operated toy car works. The battery stores chemical energy. When the toy car is turned on, this chemical energy is converted into electrical energy. The electrical energy powers a small motor inside the car. The motor spins the wheel and it makes the car move. So this is how chemical energy is finally transformed into kinetic energy. Now let's look at how a simple bulb transforms energy. When you switch on the bulb, electric current flows through it. The current passes through a thin wire called a filament inside the bulb. This wire heats up and glows brightly, producing light energy. So, electrical energy is changed into light energy, allowing us to see in the dark. When you switch on the fan, electricity flows into it. Inside the fan is a motor. This motor uses the electricity to rotate a shaft. The rotating shaft spins the fan blades, creating breeze. So this process transforms electrical energy into kinetic energy. Let's see how electrical energy is converted into chemical energy when we charge a phone. When we plug the charger into a phone, electrical energy flows from the charger into the phone's battery. Energy is stored chemically. Inside the battery, chemical reactions take place. These reactions store the incoming electrical energy as chemical energy. That's how the battery gets charged and is able to store power for later use. As the battery gets full, the flow of electricity slows down. Eventually, when the battery is completely charged, the phone automatically stops charging to prevent overcharging. So in this process, electrical energy is successfully changed into chemical energy inside the battery. What did we learn in this session? Energy transformation helps us use energy in useful forms. In our daily lives, energy is not always in a form we can use daily. For example, we cannot use chemical energy from coal or batteries as it is. So we convert it into other forms like heat to cook food, light to see, or we even convert it into motion. So this process of changing energy from one form to another is called energy transformation. Different devices need different types of energy. So each machine or living thing needs a specific form of energy to work. A fan needs electrical energy to spin, while a plant needs light energy from the sun to make its food. That's why transforming energy into the right form is important. Many daily devices rely on energy conversions. We saw how a solar panel changes light into electricity, how a battery-powered car converts chemical energy to motion, and how a speaker turns electrical signals into sound. These are just a few examples. Almost everything around us works through some kind of energy conversion. Understanding energy changes helps us design smarter and cleaner technologies. Knowing how energy is transformed helps engineers build better and more eco friendly devices. From solar powered lights to rechargeable batteries and electric motors, these inventions depend on converting energy efficiently.